All right, just a short video to explain the internal channel structure of the Nano Channel chip. But starting all the way from the beginning, we can look at the chip as it looks from the outside, because that's what you'll see when you look at it in the lab. And we have the top side here, which is just containing a name and an ID number, and the central window where your nano channels are. And if we go to the bottom side, it looks more like this. It also has the central window. That's where the nanochannels are suspended on a membrane right in the middle. But it also has the four inlets of the chip. And if you look into the central window of the chip, you'll see the field of view of the chip, which is typically 500 or a bit more micrometers wide and about 100 micrometers in the other direction. And just to clarify, these four inlets to the side are what need to be poked open with a syringe needle before you use it. The reason why is because there's a membrane on the bottom that comes from the fabrication process, but it's actually quite nice that it's there because it keeps the chip chemically clean from air and any dirt that may make it into the chip until you want to use it. So in order to have the hydrophilic surfaces that are inside, I would recommend waiting with puncturing the chip until right before you need to use it. And then the surfaces will stay hydrophilic for at least some hours, which will make it much easier for you to fill up the chip and start a flow experiment. So looking at the internal structure of the chip, I can zoom in a little bit here so you can see that there are still the four inlets visible, and I tried to mark up the central window with this turquoise bluish rectangle. And you can see also these blue lines are connecting two inlets on both sides. And these are the two pairs of bypass channel in our chip. That means that if you choose an inlet, maybe per random, by just screwing in a tube, it could be this one, then you also know that this one will be the outlet. There's no way around that. And the same exact thing for the other side. You could choose either this one or this one for an inlet, but just know that the other one will be the outlet. And the way you keep track in the lab is because there you clearly can't see the internal microchannel structure, but you can see this rectangular field of view. And it's always longer in one direction, and it is parallel to the bypass channels in the chip as shown here. So the way your channels look are likely something like this. If we zoom in a little bit, it's a lot of different kinds of channels. Maybe some channels are just connected to the U channel, sorry, to the, they are U channels, they're just connected to the bypass channel here, and they move along a little bit and are connected to the bypass again here. So in effect, that means if you chose an inlet to the top right here, there will be a larger pressure of your liquid here because there's a pressure drop all the way through the channel. There'll be a pressure here driving the liquid into these U channels, and due to the pressure drop, it will come out on this side here. And you have various other types of channel. For example, you will have one pressure here, and if it's larger here, it will go into the channel and come out to the other bypass channel if the pressure is lower there. So that's how you can control the flow inside your channels using the syringes or the pressure pumps by adjusting the pressure you have on one side versus pressure you have on the other side. So that's all I had for now. Please ask any questions if something wasn't clear.